So next week's our test on chapter 6. The practice test, view test is already up in Alex. I just posted it there this morning. It's 10 questions again. I think that works out pretty good for the time we have. So practice it. Ask questions if you have questions on it. Use that to create your note card because that's going to focus down what you need to create your note card on. Okay, we'll have the same thing we did last time. We'll have the review on Tuesday where I go over the exact questions that were in the review. And then on Thursday, you'll have your test. Okay. Next test after that's chapter 7 and 8, and then the final at that point. So time's flying. Like next week's literally basically halfway through the class. So again, if you need help, you need any questions or anything else like that, I'm here after class. There's nobody in this room until I think 5:30. So like you can stick around after class, ask questions, get help on things. That's fine. If otherwise, I'm over in the office in the adjunct suite. Just message me and we can set up a time to come help. So I'm here every day, every Tuesday and Thursday, pretty much all day. I'm here from 9 o'clock in the morning until 8 o'clock at night. So almost all day on Tuesdays and Thursdays. All right. So today we're going to look at graphing. Graphing trig functions. So graphing any function can be complicated. You just have to figure out what the rules are for that function. So when you're graphing linear equations, you find 2 points, graph the line. When you're graphing parabolas, you have to find the vertex and those things. So you're looking for important information about the curve. And then we can graph it. Trig functions, we're going to do the same thing. We're going to create what's known as a parent function. We're going to create a table of values for that parent function. Okay? Because the nice thing about trig functions is they kind of do the same thing over and over again. They just repeat themselves. So if we have this parent function of values, we can then use that to transform to create any of the equations that we could possibly come up with. So we're going to look at each one, then we're going to do a couple of things on it, and then we're going to do a bunch of problems after that. So let's look at sine. So this is the graph of sine. What are some things you notice about the graph of sine? Yeah.
Starts at the origin.
So it starts at the origin. That's important because cosine doesn't. Okay, so sine and cosine look very similar. Actually, if you look here, that's sine and that's cosine. The shapes look very similar. The key is they don't start at the same spot. Okay, so sine starts at the origin. So when x is 0, y is 0, right? So that's an important piece of information. Okay, so that's that point right there. Okay. What's another thing you notice about sine? Yeah. So the lowest point right here is -1, and the highest point right here, right, is 1. So sine period, or better terms, is 2 pi. That means it repeats every 2 pi. That's its period. Okay? So it repeats every 2 pi. So from 0 to 2 pi, so at 2 pi right here, it goes right back to 0. So my last point is 2 pi is also 0. What about this point right in the middle here? Where do you think that point is? It's halfway between the two, right? That's 1 pi. So at pi, it's also 0. All right, so now this point right here. It's halfway between 0 and pi, right? So that would be what? Pi over 2. So pi over 2 is 1. And then this one down here is 3 pi over 2 because it's halfway between pi and 2 pi. Okay. So that is my parent table for sine. Those are the 5 points that you're going to always be looking for. Okay. Now, depending on what the sine is multiplied by and stuff like that, I can transform those points because not everyone's going to be exactly the same. So we need to figure out a way to be able to take that parent table and transform it to give me my other points. Okay. All right. Everybody got this table down because you're going to need it in the next problem. And unlike me, you can't copy and paste. All right. So this is sine of x. If we look at this equation, so in this one, what did they do to change the problem? So they're multiplying it by -3/2, right? So whatever this answer is, they're going to take that multiplied by -3/2. So in essence, they're taking the y value from here and multiplying it by 3/2. Correct? Okay. So what's 0 times 3/2? 0. What's 1 times -3/2? 0 times 3/2 is 0. -1 times -3/2. And then 0 times it again is 0. If I what I wanted to do, black out that middle one, there's the points for my new graph. So my point, it's going to be 0, 0, pi/2, -3/2, 0, or pi 0, 3 pi/2, 3 pi/2, and the 2 pi 0. I do not think we're going to try something. Nope. Actually, maybe. Sure. Okay. So this is how you're going to put it on Alex. So plot our points. 0, 0. Pi/2, -3/2. So we should remember the original sine. Those are the parent functions. That's what you need. That table. Everything we're going to do after this point is going to be basically manipulating that table to give us our new graphs. So we should memorize that. That table would be something you should use, yes. And actually, again, remember going back to the last class where we talked about the unit circle? It fits the unit circle. If you think about the signs are the y values, right? Yeah. So it starts off at 0, goes to 1, goes back to 0, goes to -1, goes back to 0. There's your points. So it goes back to remembering that unit circle and using that to create your parent table. So I think I'm going to give you a unit circle for the test. So you do not have to bring a unit circle. So I will give you a unit circle so you have a unit circle. No problem. All right, so we've plotted our points. I think, nope. Yes, I plotted our points. Once you plot your points, you hit the little graph tool, and it gives you a nice graph. If it doesn't give you a nice graph, you screwed up. Okay? So my new point is 0, 0. It's going to be negative 3 over 2 to positive 3 over 2. Okay? So what that's called that's called your amplitude. So we talked about period as how much spread it is. So typical sine will go from 0 to pi or 2 pi. That's your period. This one's the typical sine, so that doesn't change. Your negative 3 over 2, the number in front of it, changes your amplitude. It's going to tell you how much it's stretched vertically. Yes?
Does this have to do with anything with sound?
Yeah. Literally every sound wave that you can think of is a sine wave. Depending on the frequency, depending on how compressed it is, depends on the sound you get out. Your TV, your radio, everything is all done based on these radio waves. Even digital does it, but it's not a sine wave anymore. So, yeah.
I went to a guitar maker, like music maker,
Yep.
yesterday, and he had a formula like this to figure out like the vibration of the xylophone. Like he had to do something over something. I forget what exactly the formula was to get like the perfect.
Yeah, to get the actual frequency of everything.
Vibration the entire thing.
Yep. All based on the same thing. So your amplitude, so actually, if you think of, so there's two, this is going probably before most of your times. There's two bands on your radio, AM and FM. Anybody know what the A and F stands for? Amplitude and frequency. AM is amplitude modulation. FM is frequency modulation. AM is amplitude. That literally changes the height of the wave. So your sound, the actual voice that's coming out of the radio, is the amplitude wave that's above the frequency. That's why your AM radio is staticky, because they can't cut the top and the bottom, because that is actually the sound that you need. Frequency modulation changes how fast things move in within it. So they can cut the top and the bottom, which cuts off your staticky. That's why your FM radios typically aren't staticky. So it all goes back to this. So your amplitude is the number multiplied by your trig function. So in this case, my amplitude is negative, or actually it's just 3 over 2 because it's always positive. It's the absolute value of that number there. So my amplitude is 3 over 2. That means it's how high it's going up and how low it's going down. If there was no number there, it would be just 1. So in the parent function, your amplitude is always just 1. All right. Let's look at cosine. I got to remember I'm actually sharing my screen now. All right, so same concept, right? We're actually going to use the exact same. I'm sorry, am I messing up your test? Or are you done with your test? Oh, yeah, go ahead. I thought for a minute I was like disturbing your taking your test. All right, I'll see you tonight. So we're going to use the exact same points as we did for sine. So now your cosine starts off at what? It starts off at 1. Yep. So that's my point right there. At pi over 2, it's down to what? It's down to 0. At pi, it's at negative 1. 3 pi over 2, it's at. And 2 pi, it's back at 1. Yes. Okay, so if you look at this, What's the yellow? That's the sine wave. So cosine and sine waves are basically the same. Cosine is shifted 90 degrees, or pi over 2. That's the only difference. That's why I can say everything's based off the sine wave, because it's just the sine wave shifted depending on the direction you want to go with it. Yeah, pi negative 1. I think the next one should be, I think the next one was cosine. Yes, good. All right. I'm going to go back, grab it in a second. All right, so let's look at this one. This one, 3 over 4, is being done to the what? The x inside of that function, correct? Okay. This is the one you're going to have to remember one thing. If it's being done to the x, you need to do the opposite of it. Okay? You need to do the opposite of what's there. Because our goal is, in essence, to get that piece inside to be exactly the same as the zero, the numbers in my parent function. Okay? So we need to take it and do the opposite of it, basically, because we're going to end up canceling it out when we plug it back in. So we're not going to multiply by 3/4. We're going to multiply by what? 4/3. Flip it over. Okay? Because in essence, we're going to divide by 3 and multiply by 4 to cancel out the multiplication by 3 and the division by 4. So we're going to take the x's in this case, and we're going to multiply by 4/3 x. So that 0 is now still 0. Pi over 3, or pi over 2 times 4 over 3 is 4 pi over 6, which you can reduce to 2/3 pi, or 2 pi over 3. Four thirds times pi is 4 pi over 3. 3 pi over 2. So we have 12 pi over 6, which is 2 pi. And then 2 pi times 4/3 is 8 pi over 3. Okay? So again, just like I was doing before, we're now going to eliminate that. And these are my new points. That's my x, and that's my y.
It was just a whole number. You would do it.
What do you mean?
Like you would.
I would still flip it over. So if it was 2, I'd be dividing by 2 or multiplying by 1/2. You always have to do the opposite of it. Always. Every single time. It's always the opposite of it. So I got 0, 1. 2 pi over 3, 0. Pi over 3, negative 1. 2 pi 0. I would do both. No, I would do both things that I just did. So I'll do one like that when you have two different things. We're going to do stuff like that. All right, so I plot those 5 points. And I get my graph. What's the period of this one? What's one rotation from start to end? 8 pi over 3. Okay, so because remember, the original one was 0 to 2 pi, right? This one is going 0 to 8 pi over 3. So my period, to figure out my period of a trig function, it is going to be, well, I think they use b for that one. It's b. So it's 1 over b times 2 pi, if I remember right. So, and this is b. So you flip that over and you multiply it by 2 pi. Okay. So whatever, and that's basically going to give you that number there.
You put
Huh?
the 8 pi over 3.
Oh yeah, that would be the period in this case.
Okay.
Yeah, yeah. You wouldn't have to do it again. So
I just wasn't sure.
no. So okay. There's a ton of topics that are around this. A lot of the topics is how you graph them. Some of the other topics ask you for what the amplitude is or what the period is. So you don't want to have to sit there and do all this work to find the period. So, but instead of going specifically and doing a problem just to find period, which I probably will do one later on, which has a lot of different pieces to it, I figured as I'm going through and doing them, we now know how to find the amplitude. That's the number in front. We now know how to find the period. That's the number. I just flipped that over and multiplied by 2 pi. So it's like we can use the same concepts to find that information. So we don't necessarily have to, you don't have to do more stuff. All right. That's kind of where I'm trying to go with this. Like you can try to memorize a ton of stuff. If you can remember a little bit and you can use that to find the other things, it's actually sometimes better that way. And then once you get comfortable with it, then you can skip those extra steps because you know how to do the other piece easily. Okay. All right. So we've done. I'm actually going to skip tangent for a little bit, but so this is the cosine, and that's the sine. We did the same concept for both ones, right? One we did to the y because it was on the y. One we did to the x because it was on the x. All right. I'm going to skip graphing things from now on. So I'm going to switch back to this. Presenting. Let's present that. All right. Do this one. All right, so here we go. We've got two numbers now, right? So again, we're going to start off with our parent function. This is cosine. So my parent, so 0, pi over 2, pi, 3 pi over 2, t pi, 1, 0, negative 1, 0, 1. So that's my parent function for cosine. All right. We have a change to the x and a change to the y. It does not make a difference which one you do first. Okay? So the only time it matters is if you have more than one change to a specific variable. Then things are going to matter which order you do them in. But in this case, it does not matter which one I do first. So let's do the y one first. Since it's just 3, it's simple. So we're going to take this number out here. So I've got 3y. So that means it's going to be 3, 0, negative 3, 0, and 3. I just multiply all my y's by 3. Okay? What about this one? I'm going to do 4 over 3, which I believe is the exact same thing I just did a second ago, right? I flip it over. So 0, 2 pi over 3, 4 pi over 3, 8 pi over 3. Oh, no, not 8 pi over 3. 2 pi. And then 8 pi over 3. Then you just eliminate these and you graph the new x and the new y. Then you graph that equation. So if I look at three. So if we look at this, we have 0, 3. Two pi over 3, 0. 4 pi over 3, negative 3. 2 pi, 0. 8 pi over 3, 3. Those are the 5 points I just got.
So for sine, would it be the same type of thing?
Yep. Nothing changes. If you notice, like I haven't actually changed the rules for sine and cosine. They're exact. And actually, the rules that we just did for these works for any trig function. The only thing that changes is the parent function. Okay. So if I wanted to do tangent or secant or cosecant or cotangent, any of them, it doesn't matter. The same rules that we just did for these apply to all those. The same process applies. The only thing that changes is the parent function that I start with. I would start with the one for tangent or the one for cosecant or whatever it happens to be. Okay. All right. This is tangent. Tangent's a little messier. And tangent's actually the only one that we're not going to use the like 0 to 2 pi type thing. We're actually going to use, we're going to look at just this piece right here. Oh, I didn't switch over. There we go. There we go. And she's like, remember, tangent is a division, right? It's sine over cosine. So when cosine is 0, that's the division part, tangent doesn't exist. When is cosine 0? At pi over 2. At 3 pi over 2. That's there and there. That's why there's vertical asymptotes there. Okay? It also doesn't exist at negative pi over 2 and negative 3 pi over 2. That's why those other lines are there. So when we're looking at tangent, we're going to look at this piece in the middle. So my tangent parent function is going to go from negative pi over 2 to pi over 2. And I'm going to do negative pi over 4, 0, and pi over 4. Because again, we're still going to cut it in half. All right. At negative pi over 2, does tangent exist? No. So it's undefined. Doesn't work. The nice thing is you can't do anything with it. It's always going to be undefined there. So if I tell you to multiply undefined by 3, it's still undefined. And at pi over 2, it's undefined. What about at 0? No, at 0 it is 0. All right, who remembers the unit circle? I literally taught it Thursday. This is true. I will give you that. All right, look back at your notes from Thursday. Look at the unit circle. Look at pi over 4. What do you notice about sine and cosine at pi over 4? They're the same. So if I'm dividing them, What's tangent going to be? 1. So at negative pi over 4 and pi over 4, tangent is 1. Okay, so there's my parent function for tangent. I need tangent. All right, so there's my parent function for tangent. So let's use it. All right. So it was way worse before class started, so I'm not going to complain if it stays like this. All right. So let's do the y first because y is always the easier one. What am I multiplying the y by? Negative 3. So undefined is still going to be undefined. That'll be your vertical asymptote. 1's going to be 0 is going to be 1's going to be. Oh, sorry. One of those is negative 1. That's a negative 1, not a positive 1. So that's just going to be 3. And then undefined is going to be undefined. What am I going to multiply the x by? 3 over 2. So this becomes negative 3 pi over 4. Negative 3 pi over 8. 0. 3 pi over 8. And 3 pi over 4. Huh? So I'm just making all the multiplying all the x's by 3 over 2.
So the same rule goes sine, cosine, tangent.
And secant, cosecant, and cotangent. Everyone. Always this flip. Even if it's a whole number, you make it a fraction.
So if we're graphing that, we're just gonna graph those 3 points.
And the 2 asymptotes, which I'm going to show you right now.
Okay.
All right, make sure you have those numbers down because I'm going to, yeah. Yeah. Yep. Yeah, tangent's the weird one because it doesn't, it repeats every pi instead of every 2 pi. Good question, though. And the amplitude for tangent doesn't exist because it goes from negative infinity to positive infinity. It's a ratio. Tangent's a ratio of sine and cosine. That's actually why it exists, just because it is a ratio. And it was easier to write tangent than always write sine over cosine. So I told you, mathematicians are lazy. If we can make things easier, we're gonna. Well, easier for us. All right, so here's Alex. We're going to put it in Alex so you can see how to graph this one. There is vertical asymptotes and horizontal asymptotes here. We need to use those. Where was my first vertical asymptote? Actually, first off, always plot your points. So my first point. Oh, negative. It was 3 pi over 4, right? And I'm just going to use 0 for this. I know it's not 0. I know it's undefined. I need that point there so I can draw my line through. Okay? And then the next one was negative 3 pi over 8, right? I haven't drawn anything yet. And that one was -3, right? Oh, +3. That's right. This one flips. 0, 0. Yeah, I'm going to show you how to get rid of that in a second. Then we had 3 pi over 8, and it was -3. And then we had 3 pi over 4. And I'm just going to put 0 for that one so I can get my asymptotes. Okay, so now my asymptote was at -3 pi over 4 and +3 pi over 4. Notice once I click the asymptote, the dot disappears. Okay, I'm using that just so I make sure I put my asymptote in the exact right spot. My other 3 points are there, so now I can click my graph and it graphs my equation. Okay, so when you're plotting your points for undefined, just use a 0, and then you can use those to click where your vertical asymptotes go. And then the other points graphs the equation. Okay. I was just going to say it's not there. My suggestion to you, take a picture. There's all 6 of your parent functions. Hold on, I'll move my water bottle out of the way for you. And I'll move out of the way. It's going to be on the back of your unit circle. I just don't feel like having to constantly keep writing them, and we're going to use these a bunch in a minute. Everybody got a picture now of them? Okay. Those are all the parent functions for sine, cosine, tangent, cosecant, secant, and cotangent. Notice how your cosecant, secant, and cotangent do also have undefineds in them, because again, they're ratios. It's the cosecant goes with sine. It's 1 over sine. So where sine equals 0, cosecant can't exist. Same thing with secant, where cosine equals 0, it can't exist. Cotangent is where sine equals 0, doesn't exist. Okay, so those are the values. Also notice, so the tangent and the cotangent are the only ones that use weird, not the 0 to 2 pi type things, because you need points between the asymptotes, basically. They're cosecant and secant, it's the same thing. It still goes 0 to 2 pi for those. All right. For all intents and purposes, you now know how to graph any trig function I give you. Now we're going to do some crazier ones so you can deal with the more oddball problems. But nothing that I just told you is going to change. All right, I just need a problem. Really, it's all I'm literally going and getting at this point. Let's do this one. There's a few graphing ones on there. All right. I just said I told you everything you need about graphing. I put this one up there and I see faces go, oh. What's the first step? What do I need first? I need my parent function. Before I do anything, write down your parent function. All right. What's done to the X and what's done to the Y? Okay. Yes. Okay. Yeah. Parentheses are very important here. And you said that. There's no parentheses here. If this was this way, the 3 is being done to the X. Okay. Since it's not, the X is nothing done to it. It's just the Y. Okay. Since it's just the Y, order of operations, we're doing 2 things to it now. Okay, we're going to do 2 things to the Y and nothing to the X. And order of operations still holds true. So what will we do first? Right, we're going to take care of the multiplication first. We're going to multiply by negative first. Then we're going to add the 3. Okay, so we have negative Y. So negative 1, 0, 1, 0, negative 1. And then negative Y plus 3. So negative 1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. 3, 2. Did any rules change from what I've already showed you? No. You're still doing it, starting from the parent function and making those transformations to it. The only difference is this time I'm just not multiplying. I'm adding something. Okay? So, but the process is still the exact same. All right? And if you graph this one, this is what it would look like. It's shifted up. It shifted up and flipped over, basically. And we have the values of 3 in the middle, which we typically don't show because it'll align.
Why do you send the negative back to the Y?
Because it's not inside parentheses with the X. So in essence, what you're doing, because remember, if I take, so I'm saying my parent function is cosine of X, right? I'm saying my parent function is cosine of X, right?
Yeah.
What am I doing to that function? What am I, so we'll say this answer is M. We'll just make a letter up, it's M. So Y is negative M plus 3. So whatever this answer is, which is that column right there, that's, so not that one. That column right there, that's what I'm doing the negative and the 3 to. Okay, that's why I'm doing it to the Y, because in essence, that's the answer of cosine of X. Okay? Yeah. So it's minus whatever the value is plus 3.
So let's say that we're
I would have multiplied it by 2 and then added 3. I'd have said 1 times 2 is 2, plus 3 is 5. So the first one would have been 5. Yep. So you'll notice that this is shifted up. Oh, sorry. Equals 3. So there's your values for. Okay, because so when you graph it on the x-axis, it automatically puts the points for the x-intercepts in there, which is nice. Since this graph is shifted up, right? That line is no longer on the x-axis, so it didn't give it to me. So I had actually physically put the line in there so you could see them. Yeah, that's why, because it's shifted up. That's where that +3 goes. So when you're looking at it, the number at the end here shifts it up or down. Okay, so if this was -3, it would have shifted down. Yeah, exactly. That's in essence all we're doing. That parent function, we're doing our transformations to our parent function. Okay, that's it. So if you remembered your transformations, we in essence did negative f of x plus 3. And that part of the thing. So, okay. And then our amplitude on this one is still 1. Yeah, that's all we did. We didn't do any extra math. We literally did what you just said. Right. That's the difference. That's the only thing I did extra. And I wrote it down so you could see what I was doing. But yeah, if you know like those things, you don't necessarily have to write every little piece out to get it. Like you could have done those two transformations at the same time. You could have said, okay, negative times 1, -1 plus 3 is 2. Okay, that's my next point. Okay. Remember though, when you're looking at it in terms of Alex, though, you need to make sure your points are exact, and it's really hard to get like pi's over 2's and those things in there. So that's where using the plot tool to type in the points is important. Yeah. There are topics in Alex that deals just with transformation. So actually, this one is literally a transformation topic. Okay, so it's like you literally take it. Okay, now it's shifted. You're shifting. That's what you're doing. Okay, so there's topics in Alex that you're just, it's literally how would you transform? Okay, I'm going to shrink this one, or I'm going to extend it out, whatever happens to be. Okay, or flip it over. Not that way, that way. So you can do those type of things. So it's just a matter of how Alex is asking you to do it. Some it asks you that, some it asks you. So I closed the screen before I shared it. That's fine. Someone asks you to plot all the points. Someone asks you to transform it. So, all right. So let's do. Where's my whole screen? Let's do this one. It just happens to like cosine today. It just keeps giving me cosine ones. It doesn't change if it's sine or cosine. It's just a different parent function. So that's why I'm not overly worried about making sure that they're different ones. All right, take a minute and try it. Your y should have been easy. What am I doing to the x? Huh? Nope. Nope.
Oh, it's 3 over.
No. Who said add it? We're going to add 2 pi over 3. Remember, always do the opposite. So we're subtracting. The opposite of subtraction is addition. So we're adding 2 pi over 3.
Oh, okay. It's still 2 pi over 3.
Yeah. We're flipping it when we're doing the multiplication and division because that in essence is the opposite of multiplication and division, is flipping it over. In addition and subtraction, the opposite is the opposite operation. So 2 pi over 3. 2 pi over 3 plus pi over 2 is, yeah, you got to put them together. I know, that's what I'm sitting there trying to do it in my head real quick, and I'm like, or 7 pi over 6. Pi over 3. 4 plus 9 is 13. Pi over 6. And 6, 8 pi over 3. 6 plus 2 is, yeah. Yeah, and the y is just going to multiply by 3. All right. What's your period for this one? What's in front of the x? What's the number in front of the x? It's 1, right? So your period's 2 pi. What's that minus that? 2 pi. Your period's from the beginning to the end, right? This is easy. 0 to 2 pi is 2 pi. If this is 0, it's simple. Last one. If it's not 0, because you moved it. You have to subtract them. Or, again, just look at the number in front of the x. In this case, there is no number in front of the x, so b is 1, so therefore my period is 2 pi. We're going to look at that in a little bit more in a minute in the next problem. This right here is known as a phase shift. It's moving it left and right. Okay. So we've got 3 cosine and over 3. So if we looked at this graph, so there's my 2 pi over 3. Notice how it's shifted over. Because that point normally would have been right here at 1. Or in this case at 3, because it's the amplitude changed. So that right there is known as a phase shift. It's shifting it over. Okay. Now we have our 7 pi over 6, our 5 pi over 3, 13 pi over 6, and 8 pi over 3. Yes. Yeah. If the phase shift was pi over 2. It could be actually in that case either one. So if your phase shift is pi over 2, because that's the shift, from sine to cosine, they would look identical. Okay. So there's your sine, there's your cosine. Okay. So that pi over 2 shifts them so they're identical. Yes.
For a second, that graph looked like some kind of ropes course. So
All right. So that's known as phase shift. Okay. All right. Okay. No, I haven't scared you yet. Darn. There we go. All right. Before you start doing the problem, we're going to do a few things for this one first. Okay. First off, you have 2 things done to the x and 2 things done to the y, right? In essence, this is as complicated as the problem could possibly get. Okay? It literally cannot get any more complicated than this problem. No, actually, literally it can't. Like, this is the most transformations you could do. Okay? But, so the first thing we're going to do is we're going to graph it. But we need to do something before we can graph it. Okay? I need to make a change inside the x. So I need to change this so that it's this. It's got to look like, it's got to have the parentheses around it. So whenever you have multiple transformations inside of the x, okay, I need to split the addition part or the addition and subtraction part from the multiplication part. Because remember, I have to do things opposite, right? So in essence, I have to do my addition and subtraction before I do my multiplication. So I need to make it so that that can happen. So you need to factor out that 1/2. You need to factor out whatever's in front of that x first. So if you notice, I took out the 1/2 and now I have pi over 8. Well, yeah, I can take out any number I want. As long as going back, it gives me the same answer. So if I was to multiply 1/2 times x, I get 1/2 x, right? Oh, this is actually wrong. I knew I did it backwards. That should be 2. If I multiply 1/2 times pi over 2, I get pi over 4, which is what I have. I knew I did it backwards when I wrote it. Okay, the goal is to always be able to go back. But now I've got it split. I have my addition and subtraction, which I can now do first, and then my multiplication step, which I can do next. Okay? You don't have to split pi in half? No, because the pi is nothing is done to it. All right. So again, same concept. Let's come up with my parent function. Now we switch back. It's sine. I know we've been doing cosine a ton, so don't accidentally write the cosine one. So we can do the y one real quick and easy. Let's just get the y one out of the way. We're doing negative 2y plus 1. One, negative 1. Any questions with the y? Okay, the y should be quick and easy. This real quick. All right, so first step for my x, I have to do what for the pi over 2? I'm adding pi over 2. So this becomes pi over 2. This becomes pi, 3 pi over 2, 2 pi, and 5 pi over 2. So I'm just adding 2 pi to everything. I haven't done with it yet. I have to do that too. But I'm doing it one at a time on purpose. Go. You're not done. Okay. Now I have to multiply by what? I'm multiplying by 2. So it's 2 times whatever's over here. So 2 times pi over 2 is? Pi. 2 pi, 3 pi, 4 pi, and then 5 pi. You might be mad at me. I think I did that backwards. I did do that backwards. You can get mad at me. I'm sorry. You have to reverse those two. You have to do multiplication first, then division, or then the. Yes.
So we could do the outer parentheses first.
Yeah, you do the multiplication first.
So you do the 2 first.
Yeah, going to multiply by the 2 and then add the 2 pi over 2. Yeah, it does change them. I screwed up. I'm sorry. I'm allowed one mistake today. Only one. I just want to make sure these all. And then we get 5 pi over 2 and 7 pi over 2 and 9 pi over 2. I'm just graphing the points so you can see them in a second. Yeah, so you have to do the multiplication first, or in this case, you have to do this part first, and then the inside part. It's the one thing that always drives me nuts about it. The Y's don't matter. The Y's are simple. It's always the X that mixes me up. So you're doing the opposite, but you're not doing it in the opposite order of PEMDAS is the problem. Isn't it? You do PEMDAS still holds. So this is what okay. So these are your points. Those are your 5 points. That's what you get. And as I just did, I'm going to tell you to do the same. Use Desmos to check your work. When you're doing analysis, do your work out, use Desmos to check it. Don't use Desmos to do it because then you're screwed when you have to try to do it out by hand. But using Desmos to check your work is a totally accurate and acceptable way to do it. This way you know you did it right. Or if you didn't, like we just did, you go back and you find your mistake. So that's what's useful. So as soon as I did it, I'm like, wait, my point's not lining up. Oh, I did it backwards. So those are the types of things you can use. Okay. All right. We're going to use this actual same problem. So we're going to do a few things with it. So first thing we're going to look at, what's my period? Yeah, 4 pi. Okay. So if we're looking at it, it's from that point to that point, right? So you can look at this and figure out, okay, it's from pi over 2 to 9 pi over 2. That's 4 pi. If we didn't have the graph of it, remember, your period is always 1 over that times 2 pi. So that right there is B. So your period is 1 over B times 2 pi, which in this case, so this is, let me make sure I pick the right letters based on what Alex uses so you can match things up. Because the lettering doesn't really make a difference in the grand scheme of things. They use A, B, C, D. Okay, they actually just go right across. So it's Y equals A sine B X plus C plus B. Yes. All right, so your period is 1 over B times 2 pi. So in this problem right here, that's 2 times 2 pi, which is 4 pi. All right. Your amplitude is what? Huh? It is 2. It's the absolute value of A. It's the number in front. So in this case, it is the absolute value of -2,
So if there wasn't
which is 2.
anything in front, it's just one.
That's 1. Yep.
So it's always the number before side.
Yes. Your phase shift. No. In this problem, how far did it shift over? If we looked at the graph. So remember I'm actually going to take away that 1 real quick. Actually, I can't take it away. So remember, I'm just going to put a point at y equals 1. All right, so remember that's the line, right? So we shifted this up by 1, too. So on sine, where should that point have been? It should be right here at 0, right? So it was shifted over by pi over 2. Where did we see the pi over 2 here? It's this number right here, right? Yeah. Which basically ends up coming out to be C divided by B. So you're, yeah. So it's always C divided by B. So in this case, it's pi over 4 divided by 1/2, which is pi over 2. I think it's the absolute right. Sorry, it's negative. It's the opposite of whatever's there. So remember how it's basically, it's got to be, so in this case, it's a minus. So when you pull it out, it's pi over 4. It's the opposite of whatever sign is at C. So if you want, you can put the negative sign there, and that reminds you to always change the sign. So technically it's not, but that's an easy way for you to remember it. No, it's this divided by that.
It's always going to be positive.
No, it could be negative. You could shift negative or positive. It's just going to switch. It's like if that was a plus there, your phase shift would have been negative pi over 2. It's just opposite of whatever they're giving you in the problem. The other way you can look at it is if you pull this out like this. So if you're graphing it, it's whatever number is there, because that's always going to be, that's what you already did that process. And that's where the positive, it switches the sign. Okay. So that's your period, your amplitude, and your phase shift. Your vertical shift, which is the only other thing that we could possibly have. Yeah, in this case, it's 1. Is D, which in this case is 1. That's going to be your shift up and down. All right. We want to do. I'm just looking for a problem real quick. Because I haven't done any secants in those, so I want to do one of those first. Do not have it. I might just make one up. Oh, there we go. There they are. All right, so let's do this one. All right, try this one. That should be your parent function. Remember to make sure you use the one from cosine or cotangent. The vast majority of problems are not going to have 5 things to do in the problem like we did in the last one.
What?
Which one? The second one?
Pi over 4.
Plus pi over 4.
Yeah.
is 2 pi over 4,
Yeah.
which is pi over 2.
Man.
It's fine. Here's the nice thing. When you graph them in Alex, you don't necessarily have to reduce your fractions because you're typing into the point, so you don't have to. Okay? And then we just graph those points, which I think at this point you can do. So I'm not going to do those, but that's how you find them. No, it's like the rules don't change. Like, and that's why one of the things that when Common Core and everything else first got created, I was working with the state and stuff like that, actually working on the state one for the state of Connecticut. And they put a ton of transformations in there. And I'm like, why? It wasn't until like the next year I taught pre-calculus here and I taught this lesson that I'm like, transformations work great. Because you're not like normally you'd have had to pick points and try to figure things out, graph it. That's how we used to do before. Now it's literally just looking at the parent function and doing the transformations. It works so much easier and it's so much more intuitive than doing it the other way. Because in essence, what you're trying to do is you're trying to find points that would work with the 0 to give you those points. So you'd have had to guess, oh, I got to put in pi over 4 to make that 0. It's like, just add it and you got the answer. You don't necessarily have to do all that extra work. So it does definitely make life a lot easier. Even as much as people hated it when it first came out. So, but that's graphing of trig functions. Yes.
Anything like backwards of like organic graph.
Yes. Well, I don't know on the test. There's a couple topics in Alex that does that. And I might do a couple of those next class because I got to go. There's a couple other things I got to do, like the word problems and stuff next class. To hit that, I might actually do one of those in there too. The key though with those is looking at your period, your shift, those things. Like if you can get those letters, it's just plug and play. So we'll work on that. Yes. I don't know if I have that on the test, actually. I might not have put that on the test. Because I only have 10 questions and there's like 90 topics. So I can't choose them all. No, I choose ones that are going to help you going forward. Yes, I do have that topic on the test. You too.
See you Thursday.
See you Thursday. I do not have a question on the test, though, going from the graph back. So, oh, actually, I take that back. I do. It's okay. We'll do that next class. I'm going to do that in the word problems.
I already like that stuff out.
Yeah.
Have a good one.
You too.
Thank you.
You're welcome.
Good one.
You too. I need.